Across rural South Africa, the most vital machines run on the most expensive power on Earth. A diesel pump can cost 9 rand a kilowatt hour. Solar owns the day, but the night falls back on diesel. This is a wind technology built to take the night shift, and it begins with a triangle. This is a Golden Gnomon. 2 equal sides and a base longer than each by exactly phi, the golden ratio. 10 of these sails on a frame of 30 struts meeting at 12 nodes form an icosahedral rotor. Count them: 30, 12, 10. And from directly above, the outer nodes trace a perfect decagon. Most wind turbines must turn to face the wind. This one never does. It spins on a vertical axis, so wind from any direction drives it the same way. No yaw motor, no tail vane, no waiting in a gust. That is why it can even work between city buildings, where the wind is funneled into fast, shifting canyons. Wherever the wind comes from, it simply turns. Now the elegant part. As the wind pushes on each sail, those forces try to shove the rotor sideways. But the 10 sails sit on a decagon, and the sideways pushes cancel, vector for vector, to almost nothing. The residual is 1 times 10 to the minus 16. The wind spins it, but it never leans on it. Because the frame is open, most of the wind passes straight through. Some of that is lost power, and we will say so plainly. But an open rotor survives storms, sheds gusts, and needs no heavy tower. It agrees with the wind, instead of fighting it. So how much energy? Power rises with the cube of the wind speed. Double the wind, and you get 8 times the power. Our reference design, the 1200, has a swept area of 11.84 square meters and makes about 1.3 kilowatts at 8 meters per second. It starts turning at just 2.5 and furls itself for safety at 15. And here is the real point. This is not one product, it is one geometry. Because the shape is fixed by the golden ratio, only its size changes, and the swept area grows with the square of that size, so the power scales with it. From the 1200, the same mathematics defines a family of 5 models, from a 1.3 kilowatt homestead to a 12.7 kilowatt community unit. Only the 1200 is fully drawn. The rest is the roadmap. And you need not build big. Deploy a swarm of small units, so a community grows its power 1 unit at a time. And if one stops, the rest keep turning. So where does this win? Not everywhere. And the honest answer is a map. The simulator shows South Africa's wind zones, so you can plan a site before spending a single rand. It suits a farm, beside the borehole and the cold room, and it suits the high, windy escarpment, where the winter wind arrives just as the cold chain season needs it most. And what does that cost? At a steady 5 meters per second, about 2 rand 35 cents a kilowatt hour, against 9 rand for diesel. It will not beat midday solar at 1 rand 15, and it is not meant to. It competes for the night kilowatt hour and the diesel kilowatt hour. And there, it pays for itself in under 2 years. And it works best not alone, but beside solar. Solar owns the day, the GDR owns the night and the winter. Together, the wind fills the hours the sun cannot. So you need a far smaller battery, and the battery is the most expensive and first to fail part of any off-grid system. R2.35 at night against R3.30 from a battery or R9 from a diesel generator. It does not compete with solar, it completes it.
And it is built to be built here. 30 galvanized struts, 12 hubs, 10 sails cut from shade cloth on a template, and a direct drive generator with no gearbox to fail. Over 85% of its value is local, against roughly 10 for an imported machine, made in a small workshop a trained operator can run.
And step back, because this is bigger than one machine. South Africa's wind is already here, mapped across the whole country and free every night. A technology designed to be built here and deployed at any scale means power made where it is needed. On the farm, in the village, in the town, without waiting on a strained national grid. It means a machine that is over 85% South African, and the jobs, the workshops, and the supply chains that come with making it at home instead of importing it. And what we can build for ourselves, we can build for our neighbours across the region. This is not just a turbine. It is a chance to make our own power with our own hands.
So where does this go? The 1200 is fully engineered, mathematically verified, and the patent is filed. From here, the program is clear. Build the first prototypes across the family, instrument and test them, and put the results to the CSIR for independent validation. Then fabricate locally, over 85% South African by value. This is an open invitation to partners and to funders to take a proven geometry from one machine to a whole family. Every figure in this film is live in the simulator, so run the wind yourself and watch the mathematics turn.